Good afternoon everyone, welcome back to Question a Day. It's July the 12th and we're going to answer yesterday's question on trigonometry. So hopefully you have your calculators ready because it's the first where we'll have to actually use our calculator to solve the problem. And before we begin, today is my sister's birthday. If you want to wish my sister a happy birthday in the comments, her name is Sarah. She is 19 today. But without further ado, let's continue. Let's attempt this question. So first off, we have sine theta is equal to 3 over 5, and we're wanting to solve this between 0 and 360 degrees. So first bit of information, we should think about what our sine, and for our later question, our cosine curve and our tan curve should look like. But a little, very quick sketch. Our sine curve is going to start at 0, it's going to go up to 1, back down to 0, down to -1, then back up. And each interval here is 90 degrees. So that's 90, 180, and 270, and then 360. Now we're looking for our solutions between 3 over 5, which means we're looking at a solution on the top half. There's going to be 2 of them in our range. You can see that there. And we're going to place this, we're going to put it into our calculator. So we go to calculate, we're going to do the inverse sine of 3 over 5. We're going to get the answer to that is 36.86989, a whole bunch of decimals. So our first solution for part A is theta is equal to 36, and we'll just do it to 3 significant figures. So 36.9 degrees to 3 significant figures, so 3SF. That's not our only solution. So we've got our symmetry here, so I'll just make that, there you go, so you can see that a little bit better. We're going to use the symmetry of the sine curve and say, well, our other solution, so our other solution is going to be 180 subtract 36.9 degrees. It's because we've got this bit here, 180, this distance and this distance must be the same. So we can take that from 180 to get our second answer. And when we do that, so we put 180 subtract answer, we get that our other solution is theta is equal to 143.13. We said 3 significant figures, so let's just call that 143 degrees. Again, to 3SF. Lovely. Okay, so that's our first problem done. Our second problem is sec theta is equal to 3. So take this problem, we've got sec theta equals 3, and we want to remember what exactly sec is. So sec is 1 over cos theta is equal to 3. Now we want to rearrange this. We're going to multiply by cos and divide by 3 to get this taking us to cos of theta is equal to 1 divided by 3. Now we'll think about the shape of our cosine curve. This curve starts at 1, it goes down to 0, down to -1, and then back up to 0, and back up to 1 in a space of 360 degrees. So now we're looking at the top half, so our 1/3 solution is going to be on this dotted line. Again, you can see I'm not being particularly precise. It's not necessary to be as accurate as possible in your drawing. It's more going to be helpful for us looking at the symmetry. So we take our graph, we take our calculator. We're going to do the inverse cos of 1 over 3. And that's going to give us 70.528 degrees. And again, stick to 3 significant figs. Theta is equal to 70.5 degrees. Next of all, we can use our symmetry. So this distance from 0 to 70.5 is going to be the same as a distance from 360 to our other unknown solution. So we can do, instead of 180 subtract, we're going to say theta is equal to 360 minus 70.5 degrees, which gives us an answer of 360. Take our answer, that's going to give us 289 degrees. There we go. And last of all, we've got 3 cos theta is equal to 4 sine theta. So for C, 3 cos theta equals 4 sine theta. We'll get that on screen. And what we want to do with this one is we want to convert this into a tan. So you'll remember that tan, from your trig identities, is equivalent to sine divided by cos theta. We can do this calculation by taking cos theta, so dividing through by cos theta, dividing through by 4, and we would get that sine theta divided by cos theta is equal to 3 divided by 4, or tan theta is equal to 3 divided by 4. Again, we're going to go to our calculator, take the inverse tan of 3 divided by 4, which is 36.86 degrees. Okay, so theta is equal to 36.86 or 36.9 degrees. Oh, that's nice. That's interesting. This 36.9 degrees is the same as this 36.9 degrees. I wonder if there's a reason for that. You can have a think about that if you want. It's to do with the definition with triangles. So this is equal to the opposite over the adjacent. And I'll let you think about what this one might be equal to as well. So that's a little bit of an extension if you want it. Last of all, we need our other solution. Now, if we think about our tan curve, what this does, starts at 0, goes up to infinity, we have an asymptote at 90 degrees, and then we repeat again, doing this pattern over and over and over. And we know that the tan curve repeats every 180 degrees. There you go. These are not the best drawings in the world, but again, they're practical for what we're using them for. So our next solution is going to be 36.86 add 180, which gives us our second solution of theta is equal to 216 degrees, or 217 degrees to 3 significant figures. So yeah, we'll pop that down there. Sorry, I didn't have that on screen, but yeah, so theta is equal to 217 degrees. That's all for today. We'll pick back up tomorrow. Thank you very much, everyone, for watching.